Timur Doumler.
And we'll quick introductions on on who we are. I've been in video games since 2002, and the whole time I've been the audio programmer, either for the whole company or just for the game I was working on. A lot of different games under my belt, everything from AAA titles to slot machines, little tech demos, and everything in between. I'm also the author of a couple, or the editor and author of several chapters on a couple of game audio programming books from CRC Press. Then we'll hand it over to...
Me. Hello, my name's Davidson. I'm the Principal Coding Manager at Creative Assembly, makers of Total War. Also Alien Isolation, Halo Wars 2, lots of lovely stuff. I've been a C++ committee activist and voter for a while now. Who knows about the C++ committee? Who knows it's actually a thing? Better. All right, OK. I'm the co-author of P0267, the 2D graphics proposal, which those of you who know about the committee might know about. I'm happy to talk to you for hours and hours about that if you choose, but this is an audio conference, so not now. 40 years of game dev experience. Yep, really. Where does the time go? And an avid musician and waveform fiddler. Although I make games, I play several instruments and try and persuade my son to play instruments too, and I love music. There we are. Next slide.
So I'm Timur. I've been working on a bunch of music software in different companies over the last couple of years. So I've been at Native Instruments, where I've done basically cross-platform library stuff and also Contact. I've been at Rolly, where I worked on noise and blocks. I worked on the JUCE team. Then 2 years ago, I joined the C++ standards committee. And I liked it so much that I wanted to spend some time working on something that is more really related to the C++ as a language. So 1.5 years ago, I joined JetBrains. I joined the C-Line team, worked on the front end for C-Line, which is the C++ IDE, kind of implementing C++ 7 features, C++ 17 features, working on the parser, this kind of stuff. And right now, I'm actually back doing audio stuff. I'm on Twitter. I'm on various different chat channels, like Include CPP, Audio Programmer Discord, CPP Lang Slack. You can find me there, Timur Audio. So let's start the actual talk. So what is this about? So obviously, we're talking about audio. And actually, most devices have audio, right? So every phone you have in your pocket has either an audio output, like the jack, or if you have an iPhone, maybe it doesn't have that. But they all have they all have audio input and output. All laptops have audio input and output. There's many other things like embedded devices that also have either input or output or both. And those are things that have been there for decades. There's been lots of development in the 90s when computers became actually fast enough to do real-time audio. So now we have all these APIs that we can use to do audio, and every device has this kind of stuff. And it's kind of a solved problem how to do that, right? So we have kind of ways to represent audio, which is kind of this paradigm that you do kind of linear PCM. You have a buffer, you have channels, you have a callback, samples, and these are all things that have been there for decades, and it's kind of the industry standard. But the surprising thing is that although C++ is kind of the most popular language for this kind of stuff because it's very good for real time, and most of these APIs are either written in C++ or compatible with C++. C++ itself actually doesn't know anything about audio, right? So if you just buy a new laptop and have a C++ compiler on there, there's nothing there to do audio. So what you need to do is you need to go in and talk to your operating system via some proprietary APIs, or you use some middleware. And so there's basically no standard way of doing this. And to kind of illustrate where we are today, I'm just going to try to figure out what's the hello world of audio. So we had something similar earlier in the talk. So basically, let's say you're a C++ developer, and you're excited about audio, you want to do some audio stuff you're learning. So you're like, OK, what's the simplest thing I could possibly do? So if you're talking about other things like classical learning how to code, it's probably going to be the hello world thing where you just output a string. So now you want to do the same for audio. So I think the simplest thing is just play white noise. Just like, for example, if you have if you're in a system where audio samples are represented with float, like 32-bit floats, between -1 and 1. It's on many platforms. That's the standard way to represent an audio sample. then you just want to generate random samples between -1 and 1 and just write them into the output buffer, and that should just go through your speakers, and then you will hear some noise. That's kind of the simplest thing you can possibly do, right? And then later you can do like a sine wave or whatever, but like this is literally like the most simple thing you can possibly do. So how do you do this today, right? It depends. Like if you have a MacBook like this one here, then you're going to be using Core Audio. And in Core Audio, this is one way of doing it. There's at least 3 completely different ways of doing it in Core Audio. So you can use the audio buffer queue as like a high-level API. It's going to be a lot of code. You can use the audio units API. There's also going to be a lot of code. You can use like the absolute lowest level, which is this, which is the absolute shortest way of doing it on a Mac. But still, you have to query these properties and get the data size and then get the data. And then you have to actually manually create and destroy this processor ID because it's actually C API, so it doesn't even do RAI or anything like that. But then actually the only interesting bit is where we actually want to call this function that just gives us a random float between -1 and 1 and write that out. So that's kind of the blue stuff here. And that's the only bit that actually is relevant. And the rest is just kind of platform-specific setup. That's quite a lot of boilerplate to do something as simple as writing out random numbers to the standard output, of like the standard audio output, right? So, okay, maybe you don't have a Mac, maybe you're on Windows, then you're going to be using one of those APIs that Windows provides, like for example Wasapi, then it's going to be looking like this. About the same amount of code, lots of setup, lots of boilerplate, and then again the relevant bit is kind of like buried in, like surrounded by all this boilerplate, again the blue code. And if you compare this, then actually the blue bit here that actually does something is exactly the same bit as the Core Audio bit, right? So it's exactly the same code that actually does the audio, and all the stuff around it is just kind of platform-specific boilerplate. Now, of course, if maybe you want to write software on different platforms, so you don't want to use Wasapi or Core Audio or like any of the Linux or Android APIs, but you want to write once and run everywhere, and then what do you do then? And then it kind of depends. Well, what are you doing? What kind of sub-industry of the audio industry are you in? And then it kind of fragments from there. So for example, if you are doing kind of DAWs and plugins, like I imagine a lot of people here do, then the most popular solution there is going to be JUCE. So you're going to end up writing some JUCE code, which is going to look something like this. This is one way of doing it with JUCE. It's noticeably shorter than the stuff before, and it's cross-platform. But here there's still problems because you kind of end up using JUCE components, or like the other way to write it would be with this audio device manager, but you end up using JUCE classes. You end up being tied into kind of a specific build system, and maybe that's what you want, but maybe not. And then also it's proprietary software. So it's a solution for some people, but it's certainly not the kind of universal solution for someone who just wants to do any kind of audio in any kind of context, and it should just work. And then again, this is kind of a specific kind of sub-industry of what we're doing. But audio is not just JUCE or plugins or DAWs or this kind of stuff. So for example, audio is also a big thing in games. And in games, you would probably use something else, like Fmod.
So this is the Fmod Studio low-level API. Here we're operating on a DSP graph rather than actually writing samples, and we create an oscillator that generates noise and kind of hook it up to the DSP graph directly. This is kind of the level that we can work at in games rather than writing individual samples. If you're using another API like Wise or ADX2, they'll have similar code to generate this kind of thing, but it'll be kind of at this level. Still a lot of kind of boilerplate, and here we've even abstracted the sample generation entirely.
So those are all great products, but they're all problematic because they all exhibit at least one of the following 3 traits. Either they're platform dependent, or they're proprietary, so you can't just use them in your software and sell your software. Or they're extremely verbose and force you to write lots of boilerplate. And most of these solutions have more than one of these traits. So, and we think this is something that maybe we should solve. So this whole idea is to just do better. And the way we think that we can improve this is to propose an audio API for the C++ standard library. And we have actually spent some work on figuring out how this API would look like and written some code. So I'm going to do the thing that you should never do in talks and do a live demo.
I'm going to hold your coffee so it doesn't spill.
Yeah,
Right.
that's disaster waiting to happen, wasn't it?
So how does, all right, so let me fire up my favorite IDE.
Would that be Sea Lion?
Right, so probably, is the resolution okay? Should I increase it?
It's not bigger.
Sorry, I didn't practice this. Scaled. Ooh. Is this better?
Not yet.
No.
Give it time.
Oh, now I screwed it up. Oh, there it is. Okay, great. So we're gonna add a new file. Right, so that doesn't do anything. Let's add a main. Right. Right, so that works. Hello world, okay, great. All right, so now we want to generate some random noise. So we need to generate random numbers between -1 and 1. So the idiomatic way to do this in C++ is to use the standard random library. So we would generate a random device. And then we would have a, what's it called? That one, yeah. So that's our generator.
Ascend Twister 19936. Yeah, it's an obvious name, isn't it?
We seed it with the random device. Actually, let's do this in here.
Nice IDE.
And then we're going to have this float -1 thing. So that would be a uniform real distribution float. Whoops.
Close angle bracket.
Whoop.
Ooh.
Just pushed the wrong. It's a touch bar. I keep pressing things I don't want to press. And that's going to be our noise. And we want that to be between -1 and 1. And then what we can do is we can just generate a bunch of those numbers. And oh, that's the other way around, right? So now it's generating floats between -1 and 1. Right, so how do we push that to our audio device? So what's the equivalent of std cout for audio? So of course, it's a bit different because we can have multiple devices attached. So what we have here is now we can do this. Include audio. And right.
Job done. Go home.
That would have been a good name for the talk.
So the stuff is currently in this namespace stood experimental because it's actually not in the standard yet. And this is kind of the namespace you put things that are not in the standard yet. Actually, let me, I don't want to type this like 5 times. Let me do using namespace stood experimental. Right. So now we can just do audio : : so here you have some stuff, like you can get a list of the current input and output devices and kind of do things with them, but we just want to get the default output device. Right, so that's it. We can print its name. And it's going to have like the obvious other properties, like buffer size, sample rate, whatever. So let's just do that. So that's now
DisplayPort.
Okay. It used to be MacBook speakers 1 minute ago. Oh, because I plugged in this thing. Okay, yeah, makes sense. All right, so now we have a device. So we need to connect a callback to it, right? So what we're going to do is we're going to do device connect. And that is now a std audio callback, and that can be anything that you can call. The easiest thing to do would be just to use a lambda. And that thing takes a device and a buffer list. And what we're going to do here?
Do you need to name the device?
Hmm?
Do you need to name the device?
Not if you're not going to use
What?
it.
Oh, right, okay.
Oh, okay. So I can actually. What?
You actually need to name that device.
Oh, yeah. No, I'm not going to use that.
Okay.
So that, like, you could query the device, like what it has.
Sorry, this is the first time we've been in the same room together. It really is.
So I'm just going so you have this buffer list here, and it has output buffers and input buffers, right? So I'm just interested in the output buffers. So I'm going to do for auto buffer in buffer list output buffers, and then we have a buffer, and then so what you can do with the buffer. So you want to sample over, we want to loop over the samples in the buffer. So there's a few ways you can do this. So you can have some obvious properties, and then you can also kind of loop it either over the channels and then over the samples in each channel, or loop over the frames, figure out whether it's interleaved or de-interleaved. We don't really care about the stuff because we just want to fill this thing with random numbers, so we're just going to get a row pointer to just the data because we don't care about like channels and stuff, and that's going to return a span of value type, which on this platform is float. So span is this new thing in C++20, which is just a kind of a pointer in the size, but packaged up in a nice STL kind of thing. And then we're going to just call the generator, right? Gen.
I think it was noise gen.
Was it the other way around? I can never remember this. There we go. So now we connected the callback, and now, I mean, if you do it like this, because the main function is going to like do that and then immediately quit, so we want to stop it from quitting, so we're just going to insert an infinite loop there. And that plays noise. So you see here, like the boilerplate that we have is basically this line and that line. And then the rest is just kind of the actual code. So we think that this is kind of a universally easy to understand way of doing audio in C++ that can work on any platform that has a C++ compiler.
It's probably the most applause for white noise ever.
So we have that. Let's go back to the slides. Yeah, so new audio API, of course.
927. Everyone loves 927.
Yes.
There's a problem, maybe?
Well, yeah, lots of standards. Look,
Thank you.
we want to standardize an interface, not an implementation. This is really important because you know how stuff works because you just simply have a function name that says it does this. It's fine. It's fine. You don't need to worry about how it actually does it. And that's what the standards body does. Now, we want a quality implementation to ship for free on every platform that has audio capabilities and a C++ compiler. I realize I'm reading out this bullet point, but it's an important bullet point. It becomes the responsibility of the vendors to actually implement the standard. It becomes their job. They have to hire the experts to do the writing and make sure that they're delivering it to all of us. There is a process for that. It's called standardization. Right, who here? Does anybody here write C++? Okay. Anyone here write C? Oh, wow, this is great. What does that do? Come on. Interview question. What does this do? Oh, come on. All right, I'll tell you what it does. No, I'll tell you what it does. It copies data from source to destination. count objects. Right. The reason why I know that, and the reason why actually you do all know that, is because there is a promise. You can do this. If you've got a C program, there's a promise that you can call that function and this thing will happen. Okay? It is a requirement of any compiler implementation that you can do that. Okay? This is great. It means we don't have to write memcopy. Writing memcopy is really hard. It actually is really hard. There's all sorts of edge cases. There's all sorts of places it can go wrong. You might want to use intrinsics on the processor, you know. Anyway, so we have a process for standardization. There we are. So this is the international standards. Do you know what? Let's do it this way. Let's go. So this is our organization. So working group 21 is the C++ committee. And what we do is people say, hey, let's put this in the language. It'd be really great, please. And we go, all right, well, let's take a look at it. Let's review it. Let's give it the proper scrutiny it needs. Now, the committee is divided up into a very large number of groups, as you can see. We have the language, and we have the library. That's the main division. So we have core working group and evolution working group, which governs the development of the language. And we have library working group and library evolution working group, which describes the development of the library. We also have a direction working group that says, oh, are we doing the right thing? Is this a good idea? Here are some ideas. You know. We also have a number of study groups. Those are domain-specific areas where people can contribute particular ideas. Now, if you look at number 13, you'll see that says HMI IO. That's where any audio proposal will have its home. That's where any discussion will take place.
And what does HMI stand for?
It stands for Human Machine Interface, Guy.
Thanks, Guy.
This is the first time we've been in the same room together. I'm finding things out about these people. All right, okay. So how do things happen? We have proposals, and they pass from, they take a fairly sedate route. First of all, let's talk about proposal numbering. Okay, so any proposal that's given to the standard starts with a P, has 4 digits, and then it may have an R, which says which revision it is. So proposal 0059, revision 8. Particular favorite of mine, ring buffers. Revision 8 is significant in that it can be revised many, many times over. You can present it, the committee can go, no, go back, fix it, round and round. You might see D numbers, that's a draft proposal that's not ready for publication yet. So before you send something to the committee, you'll say, oh, look, here's a draft, and you'll send it amongst your friends, and they'll say, can you edit this, can you look at this? It's fine. You also might see N-numbered documents. A couple of years ago, everything was an N document. Now the only thing that's an N document are administrative things like minutes to meetings and stuff like that. So what happens is there is a long feedback loop. But you start off with a particular study group, a particularly focused target. They'll tell you, fix, improve, and then you'll send it along the channel to the library evolution working group, or the library working group, depending on whether it's the language working group, depending on whether it's library or language. Once the library evolution working group like it, and their job is basically bike shedding. Is there much more than
Yeah,
bike
they
shedding?
bike shed names and they put const expr and no except on things.
Yeah, that's it. That's what they do. Yeah, they have a whale of a time. It's the most fun, it really is. And then we'll go to the library working group. Now, what the library working group does is make sure that you've actually worded it properly. You'll say, right, I'm going to have this function. It's going to do these things. You should not pass this data in. It will throw these exceptions. You have to say that for everything. Has anyone here read the standard? You liar. The standard is enormous. It really is. It's not your job to read the standard. It's the compiler implementer's job to read the standard. Once it gets past the wording stage, and maybe onto the core working group, it reaches its final destination. So it might go into a technical specification. This is for really big proposals, and you'll hand those out to implementers, and you'll say, all right, compiler writers, have a go with this. See what you think. See, does it work? And if they like it, or if it's a quite small proposal, then it'll go straight into the international standard, or the working draft. Every few years, about 3 years, we say, right, next standard, here you go. And all the compiler vendors go, yay, new standard, yay. And they do lots of work to make it work. More information, if that wasn't completely detailed enough, can be found at this website. If anyone would like to take a photo, now's your chance. Right. How can you help? You can join the study group, okay? Every study group has a reflector. There's a mailing list or a Google group or some way of making sure that all interested parties can keep in touch with one another. This is ours. This is where we're going to be doing all our work. Make sure you can either find it or just memorize SG13, okay? SG13, that's where you'll find all this work. Go to groupsgoogle.com, or Google Groups, it's great. It's public, it's open. you need to keep us on the right track. The worst thing that can happen is that we can do lots and lots of work with lots of people, and then suddenly, when we're all ready to go, somebody comes along and says, nah, mate, nah, you can't have that. I'm voting this, nah. We need early input, early and often. Stay constructive and positive. This is the most important thing. If we have people who start deciding, actually, you know, it should be like this, and I'm just going to shout on this reflector until I get my way, please don't do that. It's disappointing that I have to say that sort of thing. It does happen. Please don't do that. Stay constructive. Give us ideas. Give us feedback. Tell us how we can make things better, make it work, make it lovely, make it suit your needs. If we can go to the committee and say, do you know what? We have an entire industry behind us, so please stop your moaning. That's the thing. That will work. Thank you very much.
All right. So I'm going to go through the actual design of more detail of some of the things that Timur was showing you in his live demo.
Oh, just for context, like this live demo is all code that I've kind of hacked together in the last couple of days before this talk. So it's not really
It's
like complete, but
work in progress.
Work in progress.
We will be releasing an implementation of this, but the statement is that the output of this is not the implementation. The implementation is proof to the committee that, hey, look, this works and it's functional and we can get it on multiple platforms. The output of this is the standard, all the document, and the ultimate output will be your compiler implementing this. So first we have to make decisions. What are we doing and what are we not doing? So the first thing is that right now, it's a low-level device access API. There's lots of stuff we want to build eventually on top of this. We're not there yet because we have to build our foundations first. We want to make sure it's accessible on any hardware and software, kind of any software, hardware, device combination that could exist. So everything from your commodity PC and your phone, the little earbud or USB, or not, the Bluetooth things that Apple has, like those have an audio chip on them. Device with no sound hardware, big iron, exotic things that don't exist yet, everything. So we have to be very careful when we're designing this. The other thing is we want to make sure we support non-real-time use cases, things like tools, being able to say, like, run the same process in a non-real-time fashion and output the data to a file or to disk or to network or to wherever is very important. We're also deciding what we're not making. We are not right now supporting MIDI, no FM synthesis, no audio file playback yet. None of these, we want to get to some of these things, but again, we have to build our foundations and kind of make sure that we're going in the right direction there and that our foundation is solid before we can get there. So let's jump into the actual classes and algorithms. We have kind of 3 primary classes and 3 algorithms, although all these things are still a little bit in flux. We just had a delightful discussion about half an hour ago about some of these things. So all these things are in the stud, will eventually, the target is the stud audio namespace, although right now it would be stud experimental audio. So throughout these slides, assume that like using namespace is in there. So let's jump right into the device. So the device is an audio input or an audio output or input-output device. It's the endpoint. And this is what you're actually connecting your callback to, which it gets called whenever the device is ready to either accept or provide data. And so on the surface, that's all you need, right? Because you're, just like Timur showed, that you just do a little while true loop and it outputs audio. Except not quite, because you have some APIs and some devices where you can't run a thread. Embedded devices can't run threads, or maybe even if you're on Windows, the Wasapi interface is a polling interface. Now it provides an event, so you can block and wait for when your data is actually ready. So it's not just constantly polling, spinning. So we have to add a wait until suite and a process loop, and some way to query whether the device is polling, or whether the API is a polling API or a callback-based API. So your code will look something like this. You'll get your output device, you'll connect your callback to it, and then you'll spin. If it's polling, you have to call your wait and process. And if it's not polling, then you can just spin and do whatever other kind of waiting you want to do on that thread.
So just to interject, like, so this gives you the freedom to decide whether you want to kind of say, okay, there is my platform has an audio thread which is managed by it, and I'm just going to do that, or basically, you know, you can also create your own thread and do everything by hand.
Exactly. So like core audio fabricates a thread on your behalf and runs your callback in it, and Wasapi does the opposite. Like, you have to generate your own thread and drive it yourself. So this kind of gives you the freedom to do both. And on a callback-based system, the wait and the process functions are no ops. They just they don't do anything.
We're not 100% sure yet this is going to be the final solution. We just had an interesting conversation about maybe tuning it a little bit. So this is kind of the things that we really want your feedback upon. But we have a slide about that.
Exactly. So we'll talk about that in a minute. But yeah, exactly. Some of these things are up for discussion. So the callback you pass into the connect call passes a device, which is really useful if you want to use a single callback for multiple devices and check whether some property of the device and change what your callback is doing based on that. And then a list of buffers. Let's dive into what that buffer list actually is. Because the buffers provides you with a list of available input and output buffers. So these are actually collections. They're going to have begin, end, size, operator bracket, all these other fancy things. And they're actually read-only collections, because this is a collection of buffers. Now, the contents of those buffers for the output buffers are writable, and then the value type is actually a buffer, which is this contiguous list. Now, ordinarily, on basically every API that the three of us know about, there will be at most one. It'll either return to you 0 or 1 buffers. But we want to make sure this works on every device that may or may not exist and that we may or may not know about. And it's possible that there could be some device that in the callback provides you with multiple buffers. And we wanted to be able to support that, so we have some way to query the number and iterate over them and make sure that is a supported device. Now, we could have done something like this for our callback, where you pass in a vector of these buffers for the inputs and the outputs, but it felt like overkill. First, if you're writing only to output, then all the input is just noise that I have to do for ceremony, and we're trying to reduce the amount of ceremony. And also, most devices won't support multiple outputs, so having a vector, which is an allocation for a single buffer, feels like it's just undesirable. So that's why we kind of went with this manager class that can provide an optimized view into those buffers.
So just to interject, yeah, this is really important that we don't do allocation. So actually the demo that I showed earlier with the random device, that's actually not the correct way of doing this. If you call the random number generator there, it's amortized constant, so it might actually rehash the state of the whole thing in the callback. So you would not actually write it like that. You would have some, so the whole point is what we're doing here with this API is to make sure that you're not going to have any overhead. So it should be, the minimum layer that you need to write everything on top of that, like cross-platform, but it should be basically as zero overhead as possible compared to when you would do the native API thing. That's kind of the underlying design principle.
Yes. So the contents of a buffer list, the input and the output buffers are these buffers, which are what you think of as this, a contiguous block of memory containing audio samples. But what format is in it? Is it interleaved? Is it de-interleaved? Is it the API, your underlying API, will have the answer to that. The standard does not. So we have to be able to expose that and operate on data in your buffer of in any type. The data type, today we're ignoring that. We're just saying float right now. But we know that's not the right answer, because embedded devices might use int8, or maybe your device uses a big int.
I think iPhone use actually int16.
int16, and on Windows it's configurable. You can choose at initialize time what data type you want. So it's like
we've been agonizing about this, whether we should make it like a template, like a vector template, like template T, and that's like the sample type, and then or whether it should be like runtime, where you would get like a void pointer and you have to cast it, which is really ugly. And like we don't really know yet what the ideal solution is, but it should be as simple and kind of standard D's C++ like as possible.
Exactly. So if you guys have ideas, please let us know. All right, so the buffer, we have multiple ways to access the buffer data. There's channels, frames, and raw. So the raw is literally just a std span of the underlying bytes casted to the appropriate data type, as we just discussed. Then there's also ways to view your data as interleaved or non-interleaved. The channels and the frames basically return a data type that is a buffer view, which I'm not going to delve into because it's really just a view of the buffer, so you can access the individual channels directly as a unit, or the frames, and it'll automatically convert internally to the appropriate interleavedness. So again, these are collections of collections, and it kind of works as you would expect, but it's like the standardise is dealing with all these kind of collections. It's turtles all the way down until you get to the point where you actually have like data. So speaking of which, we have these algorithms to, if you need to operate on your data, or you have a buffer and you need to pass it to your device, or you need to pass it to a third-party library, then we need to be able to interleave or deinterleave the data appropriately. So your device will have some function to tell you what the native ordering of that it's expecting is. And then we need to be able to take a buffer and put it into the correct format. So we'll have 3 functions. Again, we just had another lively discussion about this today. Interleave, deinterleave, and set buffer order. So interleave kind of makes your data interleaved. Deinterleave makes your data deinterleaved. And then we have set buffer order. So all these are operating on, you notice these are random iterators. This can operate on a vector, an array, a std array, a C array. Should be able to operate on a std audio buffer. So these will operate on any kind of underlying data type that could expose these random access iterators. So set buffer order is an algorithm that, here's a possible implementation. I'm not going to go too deep into this, but it basically says, I have a buffer in this format. I want it to be in that format. Make it that, so that you don't have to write this code yourself. But again, all these things are, like I said, we just had a delightful discussion about this when we had to kind of table it because we were about to give a talk about it. There's a few other bits and bobs here. The implementation we have right now, this is very important, device enumeration. It's actually very common to have multiple devices. Your commodity PC hardware will actually have multiple devices on it, especially if you plug in your Bluetooth headphones or a different device, if you're outputting through your speakers or through the output here. This is very common. We've talked about offline rendering, some ideas about that, and some convenience naming for channels, like talking about channel : left, given a particular channel layout. So all these things are kind of either partially or fully designed into into the interface that I just don't have time to go into today.
I think one thing I would like to say about this, though, is that if you're a reactionist, okay, these are like just the absolute basics, like everyone knows how this works, and this is just obviously what an audio API does at the very basic level, and there's nothing surprising in here,
yes.
Then we have succeeded, because this is exactly the kind of stuff that you should standardize.
Standardization is about standardizing existing practice, not about making new stuff up. If everyone's doing something in one way, then you think, well, all right, there's a standard way. It's emerged. It's a de facto standard. That makes it an ideal candidate for standardization. Everything that you're seeing here should, we hope, be de facto standard. There's no arguing about this, although it turns out there is a little bit of arguing about it. But in general, this should be completely unsurprising. Nobody should be saying, you're designing. We're not designing.
Yeah, so the things we are arguing about are minutiae, not fundamentals. So putting it all together, this is more or less the code that Timur wrote. I have the polling loop at the bottom. But everything else is, again, we're connecting our callback that iterates over the output buffers, iterates over the frames here, iterates over each sample in the frame, and then writes a value. In Timur's code, he wrote straight to the raw buffer. But this is kind of this would have the same effect. We do have a number of open design questions, things we still want to do that we're not sure. We already talked about the underlying type of a buffer, talked a little bit about this polling versus callback implementation, whether this is the right, the correct abstraction for that. We know it's actually important, so some other things. We know it's important to be able to combine multiple devices into a single object, to be able to, on Windows, because you have that event handle, you can actually call wait for multiple objects, which is a more efficient way to be waiting for objects, for your callbacks. So you'll get multiple devices, and you'll get callbacks from a single location. So this is just a more optimal thing that's very important. Being able to run multiple drivers, even in a single process. So on Windows, you have Wasapi and ASIO, two different kind of low-level drivers. On Linux, you'll have a million different options. Here's just 3 of them. And then another thing we know we need to do is timestamps. When is the next callback expected to be called? this is important for some use cases. I'm actually not sure how to do it, even how to implement this on some platforms. But if that information is available, it would be nice to get. And we have a whole bunch of kind of narrow-purpose containers in this library that are very hyper-specific, but are still containers. It's like containers of containers of containers all the way down. And we're just not sure if that's the right call, or if there are some standard things we should be using. So these are the questions for like SG13 and the committee.
I have a question of Timur. Is there a ring buffer in there?
Not at the moment.
Okay.
Oh, is it P0058R8?
But that's definitely a structure that would be very useful.
Yeah.
Actually, someone yesterday pointed out another bullet point to be like, probably we should be thinking about whether you're exclusive on the device or you're talking to like operating system mixing and other things, put stuff in there as well.
Being able to access that.
Yeah. So that is probably also a bullet point in here. So there's a few things that we haven't done yet, but it should really be, these are the basics that you need.
Yep.
And not more than that.
And of course, the bike shed, all these names are temporary as what we have today right now. And the naming is totally up for discussion, hopefully once we have more of the design elements hashed out. And with that, Timur can talk about the next steps.
Right, so where do we go from here? The first thing that happened, it's not on a slide, is that two of us went, no, hang on, you weren't there.
I went.
Okay, so I went to the committee meeting in San Diego, which was 2 weeks ago, where we had the first meeting of SG13 after a long break where they didn't do anything. And we mainly discussed graphics, but also we discussed audio in the sense of, so this stuff wasn't written yet. It was more like, are you interested in this? So I just went there and said, hey, we're like a bunch of us are working on this audio proposal. We want to standardize it. Is this something you're interested in? And their feedback was, yeah, I mean, if you do graphics, then this fits into the picture, because what you want is kind of, you need graphics, kind of key events, mouse, windowing, and sound. And then basically you have all the basic bits that are there on most platforms that you need to write a basic game or a basic thing, and then it would just all be there. So they encouraged us to come to Kona in February, which is the next standard committee meeting, and actually to present this as a fleshed out proposal for standardization. And then there's going to be another meeting in Cologne in summer where I guess we're going to keep reiterating this.
Hopefully.
And currently, what we want is kind of the target vehicle that we envision is that we would not put it into the standard immediately, but we would first publish a TS, which is like a feature branch of the standard. So this happened with, there was a networking TS. I think file system was a TS as well before it became STD file system.
Modules, coroutines.
Concepts.
Yeah, so graphics is also going to be a TS, and then audio is also going to be a TS, and hopefully it's going to be finished, finished in time with some time of experience with that TS that we will optimistically be able to put it into C++23, but of course there's no way of knowing whether that will work out that way or not. Let's see. So yeah, we need your help. So this is all, the actual code is, thank you, something that, we put together very quickly, so it's kind of not complete yet, but we need a few more weeks to kind of polish this, and then we're going to actually publish this on GitHub. So, and then what we really want is the industry, so basically you people, to really look at it, look at the interface, tell us what we've missed, what we've got wrong, give us feedback, like play around with it. You can also talk to us here. There's also, so SG13 is the relevant working group in the committee, so there is an SG13 channel on cpp-slack.com, where as soon as this is published, that's where kind of chat discussion is going to happen, and then more importantly, we have this official mailing list Google group thing, which is the SG13 reflector, which is where the kind of things will be published. So this is where we're going to announce, here's the code on GitHub, which hopefully is going to happen in a few weeks. So go to this Google group and watch for this kind of announcement, which hopefully will happen soon. And reach out to us individually, on person, email, Twitter, whatever other channels. And yeah, so once the example repository is there, which we unfortunately didn't manage to do for now, but it's going to be very soon, you can download it, you can contribute pull requests, fix things, add things, more importantly, implement it. So currently what we have is the implementation that works on a Mac, like using Core Audio underneath. Obviously, you would need that to work on Windows, on Android, on iOS, on Linux. And then maybe on some more exotic or kind of embedded platforms, if someone would play around with that, that would be also really useful.
Automotive, really.
Because that's like the other really different use case that we also want to support. And that's a lot of work. So what we would also like to do is if you and the industry think this is useful and this should be an API that should exist and should work, we would need people to actually implement this properly on all of these platforms. So that's a lot of time. And you know, we all have full-time jobs, so this is all a hobby project for us at the moment. So we can't really do all this work on our own. So it would be great to get some help from, you know, get implementers to do this. Some of you people maybe just, you know, add code to make it work on this other platform. And then ideally, to get funding for this, to, you know, have someone actually work on this with some funding available, or like help us go to all these committee meetings and present it there. So yeah, if any of you think this is useful work, then we would really appreciate your help. That's it.
We have about 4 minutes now for questions.
But first of all, can we see a show of thumbs for support or non-support?
Oh.
Okay, we have general.
Couple of I see some sideways.
That's fine.
thumbs, yeah.
Couple of general. Right.
General support.
General
All right.
support. Right, we
Cool.
can take that.
Yes, sir.
So you mentioned the graphics proposal a few times.
Yes.
Oh, Mike, do we have a handheld mic for questions?
We'll have to repeat the question. We'll repeat the
All right.
question.
Okay, I know that that's been sort of gone backwards and forwards, the committee's flip-flops on
Yes.
whether it's going to go through. Have they now changed their mind that these kinds of things are likely to get into the standard?
Question is whether these kinds. So the committee didn't flip-flopped on the standard or the graphics proposal. So is this a thing that the committee now wants?
The committee's never had an opinion.
So different parts of the committee have different opinions.
Yeah.
Yeah.
The committee is a rolling group of people. It's
Yeah.
whoever turns up. History is made by people who turn up. Okay, here you are turning up, making history. You know, the graphics proposal went through periods of having massive support from the committee, and then time went on, people left the committee, other people joined the committee, and the temperature changed. And the thing is, if you're all into it and you stay into it, then it'll run through.
So I think the vibe that I got from the last committee meeting is that parts of the committee are not big fans of the graphics proposal, other parts are huge fans.
Yeah.
And this part of the committee tends to think that if we do graphics, we should also do mouse, keyboard, event loop, and
HMI.
audio. And
should
because
make-
this is kind of, this whole HMI thing is basically one big picture of, you know, this is functionality that should be available, and most other programming, or a lot of other programming languages actually give you this functionality out of the box, and C++ should do the same thing.
C++ should be a language for the desktop as well as for
Yeah.
the server, for the phone as well as for the client as well as for the server.
And right, so we're not trying to take away anything from anyone, right? So you could still, like, if you're a professional audio software engineer, you're maybe not going to use this. You're probably going to use the kind of stuff that gives you more functionality or for your platform. But like, if you just want to do audio and you want that to work, then that would be useful. If you learn, like for example, one thing that I notice a lot is that people ask me, "Hey, I know C++. You know, I want to do like play around with some audio. I'm really curious. Like, what do I use? Like, how do I like what's like?" And I'm like, "Well, depends. So either you're on Mac, on Windows, or on Linux, or you like if you're like a plugin DAW person, you take JUCE. If you're like a gamer person, you take one of the other 3 frameworks. And if you don't do any of that, then it's just so
audio
fragmented,
It's
right?
audio for the 80%.
Yeah.
Yeah.
you know,
so and then for
running out of
learning,
time.
this would be great. Yeah.
So all right. So yes, over here.
What's your opinion on an FFT being within this?
What's the opinion on an FFT? My opinion is it's a great idea, but that would be an algorithm that we would just like provide a like FFT algorithm that you could apply to a buffer in some way and get the results from that.
Your math libraries, I think, are aiming for that also, so you may be able to use an existing one.
Exactly.
I'm pushing to standardize linear algebra in the standard at the moment. There's
So
all sorts of stuff going
yeah.
on.
You talked about de-interleaving the data. 2 questions. Is that intended to be done in place? And if so, how is that compatible with a read-only input buffer?
All right. So the question was whether the interleaving is in place. So the way it currently works, it would be in place, but
Yes.
the
That's a good point.
Yeah.
We should probably provide a dual range version of this. So you could have an output iterator for the output. So this is,
Yeah.
thank you. That's a great question.
So please follow us on the Google group and give us exactly this kind of feedback. Because
All right, we
this
have
is
time
super
for one
useful.
very short question. And yes.
I think it's short. My knowledge of the standard is patchy, but you said it's an open question as to whether the narrow purpose containers are the right way to go. I'm wondering, do things like that exist anywhere else in the standard, or would this be the first time?
So the question is about these narrow purpose containers and whether or not they still exist. Guy, do you know?
There are plenty of containers in the standard. There is probably argument for more. For example, flat maps coming out, which is a new container which is contiguous and has better cache performance. I think any container which can demonstrate purpose is welcome. If we need particular types of containers to get stuff to work, they will end up in the standard. Other people can use them. With the graphics proposal, there was linear algebra and geometry, and it would have ended up in the standard. Other people could have used the linear algebra and the geometry. So, stuff we put in, stuff that gets standardized, it's in there. It doesn't just have to be used by audio. Anyone can use it. And that can be an appealing feature for committee members.
Cool. All right, so we're out of time. We're here, so please come talk to us individually. Please.